In this video, we are going to see about the compound interest. The compound interest or compounding interest is interest calculated on the initial principal, which also includes all the accumulated interest from previous periods on a deposit on a loan. The compound interest is nothing but the interest paid on interest reinvested, and the frequency that interest is computed and added to the balance is called the compounding frequency. The rate per compounding period is found by dividing the annual nominal rate by the number of compounding period. So we can find the compounding period. If it says compounding quarterly, then the period will be 4 because it is added once in 3 months. So you are adding 4 times a year. So the compounding period will be 4. If it says it is compounded semi-annually, then you are doing it every 6 months. That is, you are doing it twice, and hence that frequency will be 2. Suppose if I want to find the annual compounding, then it is just like the simple interest what we have done. If it is for just 1 year, that is a simple interest. If it is more than 1 year, then we have to do it separately. Say here we are investing only $1,000 at the rate of 6% interest for 1 year. So it is, the interest will be I equal to PRT, where P is the principal, R is the rate, and T is the time, 1 year. And the total amount A, when you add, you get that as 1,060. So you get $60 as an interest. But if you're trying to do the same thing monthly, then we have to do it for every month. So if you treat end of every month, the first month will be for the 1,000 whatever you have invested, you are going to get the interest for it. So since it is the month, the period will be 12. So you divide by 12. Computing period will be 12. So you divide by 12 and you get that as 1,005. And for this 1,005, you have to get the interest, or you can say for the 1,000 what you have invested earlier and the interest what you are getting now, you have to find the interest. So that will be the second amount. So if you continue this process, you can find the end of month 3, you will have an amount 5, 6, 7, 8, 9, and 10, and 11. And 12, at the end of 12th month, you have $1,061.68. So in this case, $61.68 is the interest amount what you get. When you do it with the simple interest rate, it will be just $60. Here you are gaining $1.68. Maybe it looks little meager because it is treated just for 1 year. If you keep this amount for a longer period, say 20 years or 30 years, then definitely there will be some significant difference here. The next compound interest formula can be treated as P times 1 plus I whole raised to n. Instead of doing it every month and adding them up, you can rewrite this as a general formula. P1 plus I whole raised to n, where I is nothing but the rate divided by the compounding period, m. A is the amount and P is principal, R is the rate, M is the number of the periods, and I will be the compounding period. So that N will be the multiplication of N and M. N will be, you'll be multiplying the period, number of period, and the number of years there. So let us take this example. You are investing $1,500 and it has to fetch an interest of 6.75, and the amount is compounded quarterly for 10 years. So when it is compounded for quarterly for 10 years, you can substitute in the formula and get the result. The answer is $2,929.50. For the same amount, let us try to find the amount which we are trying to compound daily. And daily, let us take 365 days as one case. The other case is 360 days. The reason why we are taking 360 days is usually in the bank, they treat as 360. So let us find out what is our total amount. A is P1 plus I whole raised to N. So where for 365, you get $2,945.87. Remember, when we did that quarterly, we got only 29.29, $2,929.50. See how much we get when we are investing that daily. If you're doing it for 360 days, there is not much difference. You have only same amount, but 86 cents, just 1 cent less. If you do this process continuously, if you repeat this process, so compounding frequency is increased, the number of compounding period increases will increase the value of x also. And in algebra, we know that in the limiting case, as x tends to infinity, this 1 plus 1 by x whole raised to x approaches the irrational number e. So the 1 what is inside the parenthesis will tend to e as x tends to infinity. So when you repeat this process infinite number of times, then it goes only to this irrational number e. So the parenthesis, the value inside the parenthesis can be taken as e, and the formula becomes a equal to p e raised to rt pert. For example, if p is 1000, r is 0.08, t is 5, a is 1000, e raised to 0.08 times a 5, so you get that as $1,491.83. Now let us compare our daily compounding result and the continuous compounding result. Let's do a problem with the investment of 5,000 for just 2 years, and interest rate is 8. We can find the value of compounding daily separately and compounding continuously. If it is daily, we have to use the formula P1 plus R by M whole raised to MT, where M is 365. So substituting this, we get using the calculator, we get $5,867.45. If it is compounded continuously, then it is P e raised to RT. R and T are known, P is known. Use your calculator and you get that as 65,867.55. Earlier it was 45 cents. Here it is 55 cents. So only 10 cents extra. Now, suppose if I'm doing the same thing for quarterly for $8,000, then I know that n will be 4 times 5, which is 20, and the value for I is known because 0.1 divided by 4. But here the principal value, the present value P is unknown to us. Since the total amount is given as 8,000, we are not investing 8,000, we are looking for 8,000 towards the end of the 5th year. So 8,000 is our total amount. So simplifying this, we can easily get the value for P as 4,882.17. So we got the present value when treating this quarterly. Let us do the present value when you are treating this continuously. So continuously means it is P e raised to RT. So A is known, R is known, T is known. Substitute and get the value for P. And using the calculator, we get $4,852.25. So we got the present value when we are treating quarterly and when we are treating continuously. The same way, we can calculate the interest rate, we can calculate the period, we can calculate the total number. Whatever is unknown, we can substitute the other results and get the unknown results from these formulas. So in this video, We talked about the compound interest quarterly, monthly, annually, semi-annually, and also we talked about the continuous compound interest. When you're repeating this process continuous times, what happens to this compound interest? Hope this video is helpful in understanding what the compound interest is and what is that continuous compound interest is. Thank you for listening and thank you for watching my video. Thank you.